Hello, in this lesson, we're going to talk about solving simple tangent equation. Of course, these are if statements, right? And there are functions, right? And tangent is a function, and we know its domain and range. So let's review the domain and range for tangent and arctangent, okay? Tangent, okay? Tangent function, of course, takes angles, produces a ratio, right? So we know the ARD, right? ARD as it produces ratio. And in the D, we know A very well. We know reference angle very well. And in the definition, of course, there's a point, right? X comma Y is on the terminal side of the angle. Okay, on the terminal side of the angle of A, angle A, other than the origin, right? And R equals to, we know that whole definition, which is R equals to X squared plus Y squared. Is this guaranteed? It's guaranteed that R is not zero. However, the definition of tangent doesn't use R. It uses Y over X. It uses Y over X. So, right, that's a tangent function. Arctangent, okay, arctangent. Okay, so let's talk about the domain and range for tangent. Okay, so domain and range. Okay, domain, it's all real numbers, but, right, A cannot be odd number multiples of pi over 2. And the range, is all real numbers. Negative infinity to positive infinity. Okay. And the tangent curve. Okay, we're rather familiar with it. It's at your fingertips, and you certainly know how to get it, but we talk about its meaning. And here we don't repeat it unless it's necessary. Okay. And we had a thorough coverage of these concepts. Arctangent, okay, arctan, right? Or we use a different notation, use the other more commonly used notation. Arctangent is domain, is all real numbers. Okay, we have thorough coverage of these topics. And the range, however, is between negative pi over 2 to pi over 2. Okay, and the curve of arctangent. So if we draw the picture, we let the machine does the work. It's at your fingertips if you have a calculator. Okay, so that's the curve. Okay, arctangent. So with this review, okay, we know the curve is between negative pi over 2 to pi over 2. So let me just make a little adjustment. Okay, just make a little bit of adjustment. It's between two horizontal lines. Okay, negative pi over 2 to pi over 2. Broken line, because they are broken lines. The curve never touched it. There we go. Actually, it didn't show because I need to make a little bit of adjustment to the picture. There, that should show. Okay, so that's arctangent, domain and range, right? So we have it all covered, reviewed right now. So the next topics we have today is to solve equations, to deal with the if statement, right? In the previous lessons, we talked about the if statement for sine, cosine, and now it's turn for tangent. And when we talk about tangent, we also mentioned, right, from the unit circle perspective, I'm going to put it here and another picture. Okay, but this picture doesn't allow me to, because I copied and pasted from other pictures. Is what it is that when we consider arctangent, right? So let me put it here in place. For arctangent, the quadrant 2 and quadrant 3 are up, are out. Okay, so let me just put that in place. Okay, so quadrant 3 and quadrant 2, just make sure we are reminded of that. I didn't do this review with sine and cosine. But if you have any questions, then please don't hesitate to let me know. Okay, so this is 2. And those quadrants are not used when we construct arctangent. But anyway, without further ado, right, we have discussed all of these very thoroughly. So today we're going to solve simple tangent equation. So we're still going to be talking about the three methods as we did. But this time we're gonna do a special angle for tangent, and then we're gonna cover positive values and negative values. We're gonna use, say, +1, -1, right? And tangent non-special values, say 3/4, right? And non-special values such that 5/12. How about that? Right, tangent. You can see the making of these. You can see how I make up these examples, right? How I make up these examples. The idea is very much the same. Is the only difference is the rule has changed, right? So take the first one, for example. Take the rule, for example. Take the first one, for example, right? We know this is a DRA. It's going to be from D to A, right? From D to A. So we have a tangent. So the first method, of course, you're going to think of the definition. Think of unit circle, right? Many of you are pretty familiar with the unit circle. So what we want is we want all possible values such that tangent A equals to 1. And the solution, of course, is going to be in the domain of tangent. And what's the domain of tangent? What's the domain of tangent? We just talked about it, right? A can be, the angle can be any real number, but odd number multiples of pi/2. Right? So it's a D from D to A, and we have a tangent, and it equals to 1, right? 1 is equals to 1/1, right? 1/1. What does that mean? 1/1. This is special terminal, really, right? So if you make any connections to the definition, it's going to be y/x, right? So these are the perspectives: x equals to 1, y equals to 1, right? So all of these things we can make connection of. But in terms of using this, the special, using the special, using the, what do you call it? Using the, this unit circle, right? Where, because the definition is y over x, so y over x, the blue number divided by the red number and equals to 1. And so we find the terminal. So we can find the terminal very quickly. So this is one terminal. Okay, this is one terminal, right? And there's another one, because negative root 2 over 2 divided by negative root 2 over 2 also equals 1. So we have two terminals, or two terminals. So our solution, what will be our solution? That will be a solution. Pi over 4 is one solution, right? And the pi over 4 plus pi, we get another solution, which is 5 pi over 4. So we keep going. We get all these solutions. We get lots of solutions, right? We get lots of solutions. So the solution would be what? The solution actually is going to be pi over 4 plus a k pi. That's it. Because between these two terminals, right? Between these two terminals, all right? Between these two terminals, the difference is what? This is one terminal, right? If you want to get to the other terminal, all you have to do is just plus pi, right? So to get this terminal plus pi, you get to the other terminal and plus pi. Every time you plus pi, you end up with one of the terminals. And therefore the solution will be pi over 4 plus k pi. That's pretty straightforward, right? So this is a this is a special terminal. This is a special terminal, right? If we use definition, okay, in terms of show work, in terms of showing work, it's pretty straightforward, really. If you show work, you will remove all of that, right? And then that's your answer. That's your answer. That's your answer, right? And then you may like to just draw the terminal. And you draw this terminal, right? And you may like to tell the reader this is a pi over 4. Okay, and that's it. That's all you need to show. That's all you need to show. If you want to show using unit circle, okay? So it's pretty straightforward. And the second method, okay, the second method, okay, so let us remove these. The second method is, of course, it's not using, it's don't use unit circle, right? Not using unit circle, so it's tangent that equals to 1, right? So that point is on the terminal side of the angle other than the origin. R is defined, but here it is tangent equals to 1. So we know that's 1 over 1. So we remove all of that. Now, okay. And of course, this picture is not relevant. This is a picture we did for cosine, right? So we need to move these to the other side. So to draw the picture, so I'm going to do some removing. Okay, I'm going to do some removing. And that's it. Yeah, so this is one terminal, right? And there's another one terminal. And the other terminal, we're going to draw them. So here the blue. Right? And there's the red. Here's the other terminal. So here's the other terminal. Okay. And of course, there's another red. Okay, so this is one terminal and this is the other terminal, right? If you draw such a picture, it's pretty obvious to your reader, and you will also like to mark this piece as pi over 4, right? So from definition, we get to this picture, and then you just write up your solution. You just write up your solution. Okay, so A is equals to, right, pi over 4 plus k pi. Okay, k pi, and k be any integer. K be any integer, and that's it. That's it. Just that's the second method, right? Method 3. Method 3. Let me show you method 3. You know what to expect for method 3, right? So this is 1. We're going to draw the tangent curve. We're going to draw the tangent curve. Okay, so let's remove that and remove all of these. We already know the solution, don't we? Right, so just to show how we express our work using tangent curve. Of course, we don't need this one. We're going to draw horizontal line for sure, right? So where was our tangent curve? This is our tangent curve, right? This is our tangent curve. And we know the output. The output is 1, right? So we got the angle, and the angle is the rule of tangent is applied to it. It produces the output equals 1. So we know the output is 1. Therefore, we're going to draw a horizontal line. Okay, we're going to draw that horizontal line. And this time I'm going to use purple. And there you go. And the crossings give us the solution. The crossings give us the solution. Okay, so here, solution, here, solution, right? So let's see, what is this solution? What is this solution? The solution tells us input, output. Input is angle, output is ratio, right? So input is angle. Recall how we make these curve. Okay, you see, we spend all that time make those curve, right? This is a pi over 4, right? This is pi over 4. And there's a purple ratio. There's a purple ratio, which is red divided into the blue, or blue divided by the red, right? So this is 1, right? And this one is pi over 4. The orange is pi over 4. If you recall the sections that were making the pictures, right? All of these are connected. All of these are connected, completely connected, right? So from ratio to angle, right? If the ratio is such, okay? How about this one? You add a pi, you get the next one. So the difference between these two, right, is pi. Okay? And the difference between these two is a pi. That's why we plus k pi. Okay, plus k pi, and keep going. Right, so this picture could keep going. So that solution, of course, the solution A is equals to pi over 4 plus k pi. Plus k pi, right? K being any integer. Right, that's it. That's it. So let's look at another example. So let's look at a non-special one. Okay, let's look at a non-special one. So let's look at our examples, right? We have a bunch of examples in our plan, right? So the next one is we have this 3 over 4. So I'm going to bring all 3 of them. Okay, example number 2. Example number 2, 3, 4, right? So I don't want to make sure I don't leave them out. So this is tangent, right? The ratio is 3/4. 3/4, right? So that ratio is somewhere, right? So tangent ratio equals to 3/4. Not special, not special. Okay. At this point, I think I'm going to combine the method of 3 and method 1 and method 2. Okay. Method 1 and method 2. Hold on. Okay, sorry. So I'm combine these two methods. I'm going to combine these two methods because in the next method, we're going to, we're not drawing out of a unit circle. We're just drawing arbitrarily, right? We're just drawing arbitrarily. So tangent A equals to 3/4, 3/4. Okay, so let me doing some tidy up. Okay, I still have these residuals from previous work is because we want to still show how comparable these methods are, right? These methods. Okay, so I'm gonna just cut these away, put these away, and then we get to example 3. Okay, so here we're gonna put a number 2 and number 1 and method 2 together. We know that for method 2, for tangent ratio, there's a place somewhere, okay, on the unit circle. Okay, there's a terminal on the unit circle somewhere. So if you look at it, this is 0.75, right? And I think that number is in between. Wait, this is 1, so this is in between because in this interval tangent, in this one, tangent is increasing. It's increasing, right? So it's somewhere here. So there's a terminal here, and there's a terminal over there. So that would be the terminal. Okay, there'll also be a blue number divided by the red number. Okay, so for our convenience, instead of drawing on this one, which I cannot manipulate much because I just get that from the internet, right? I'm going to draw a picture which is more reflect, so we can mark it better. Okay, so watch how I'm going to draw this. Okay, the technique you need to know for this situation is necessary for you to learn. Okay, so I'm going to draw this picture. Certainly it's not going to be the unit circle, right? So I'm just going to make a proper view. Okay, make it a proper view. This is 3, 4, right? So y is 3, x is 4, right? So this tells us y is 3, x is 4. Why? Because a point, right, by definition, right, the point, I'm going to write it down here, x comma y, right? So all that definition is on the terminal side of the angle A other than the origin, okay? Other than the origin. Okay, I'm not going to write down r because r is not needed, right? So x is 4, y is 3, because the definition of tangent is y over x. You see, from D to A, from D to A. So we're doing from, so the ARD from D to A. You see how straightforward that is, right? So X is 4, Y is 3. So we can plot those points. We can graph our terminal. X is 4, Y is 3. So that's one terminal, right? And there's another terminal in the third quadrant. In the third quadrant, they gave the same ratio. They gave the same ratio. So how much work do you need to do? Do we need to draw the red and blue? We don't really need to, but for the sake of understanding, for the sake of better understanding, okay, so I am going to draw that. Okay, the red okay, so the red, I'm gonna draw the red there, and the blue. Okay, the blue, and there's another blue. Okay, another blue. There you go, right? But you really just need to draw to identify the angle. Okay, and now it's not a special terminal. So how do we represent those angles? So naturally, you're going to assume this is theta, right? For arctangent, the range is between -pi/2 to pi/2. So it doesn't have quadrant 3 and quadrant 2. So this theta can be represented by what? By arctan of 3/4. See? And then, so in this case, the solution, okay, the solution is simply A is equals to theta plus k pi. And k being any integer. You're done. We're done. We're finished. We're finished. Method 1 and method 2. Okay, together. Method 1 and method 2 together. Okay, so that's a solution. And that's a picture you need to show. Okay. You see, as simple as that. Okay, so DRA. Okay, so tangent equation. Third method, right? Method number 3. So you probably got the drill. Okay, so method number 3, what is it? Well, it's not a special angle. So the output is 3/4. So the horizontal line we're going to draw is going to be 3/4. There you go, right? So you got this, we got those points, we got those solutions, and we represent the simplest one. We represent the simplest one, which is, this is going to be the theta, which is arctangent of 3/4. And the purple, it's the tangent ratio, which is 3/4, right? So this is 3/4, right? And this piece is theta. See, right? So the solution for tangent A equals to 3/4, whoops, 3/4 okay? And the solution would be theta plus k pi. Okay, you make sure you have to specify what theta is, okay? You must, and you can say where, okay, so these are the language you can use. Theta is equals to arc tan of 3/4. That's it. That's it. That's the solution. That's a solution. Okay. And how much work you need to show, this is how much work you can show. And in between, okay, to enhance our understanding, right? In between, this is pi. In between, this is pi. Okay, so that's pi. And that's pi. So you can keep going in both directions. Okay, pi. That's it. Solution done. Let's look at two other examples, right? With negative ratio. Negative ratio. Where's our negative ratio? We have two other examples of that we're going to cover, right? Example number 3. Okay, and example 3. And example 4. Right, so we're going to do one by one. One is a special angle, right? One is a special angle, so we're going to do the same thing, right? For special angle, here we did one special angle already, right? So we're going to put these two. No, not this one. Okay, this piece. I'm going a little faster. If you have trouble, let me know. Okay, so I'm going to basically combining method 1 and method 2 now, right? I think we can. And if you have any issues, so get back to me. So -1 this time. So this picture is wrong because the terminal are going to be what? The terminal are going to be this one. That's a negative ratio for tangent, -1 ratio, and this is another one. Okay, so we need to change this picture completely. We need to change the picture completely. So let's do it. Oh, so let's see. Okay, we just need to move everything, move to the other quadrants, right? So we're going to do that. Okay, and this piece that's in the first quadrant, right? That's a terminal. The red. The blue. The red stay. Let's see what we get. Oh, how ugly that is. No problem. We can gonna move that one. Okay. This might be the problem. Yeah. -√2 or 2, 0. And this is negative, that's why. Oh, that should go up, sorry. That should go higher. There you go, this should work, okay. So we're there, just one more red. There, okay. Now the interesting thing is, because it's a negative ratio, because it is a negative ratio, right? So we know this angle is going to be what? Negative pi over 4. Negative pi over 4. And then you just plus k pi. You just keep plus k pi, we get to the other one, right? So the solution would be, the solution is negative pi over 4 plus k pi, plus k pi. And k being any integer. K being any integer. That's it. That's it. Okay, so method 2 and method 1 together, right? So example number 3. Okay. The third method, we're going to take the method 3. The method 3, right? The above are for method 1 and 2, right? Right, so we got the solution. So here, just put the solution over here. I just want to put things as nicely to you as possible, so it doesn't have any confusion. So that's how you show work from here, from the question, and you don't only have to show one of the picture. I will show the latter picture. Okay, I will show the latter picture. Method 3, of course, we draw a horizontal line, right? We draw a horizontal line, but this horizontal line is -1. Okay, so the horizontal line is y equals to -1. There you go. Hold on. I need to put a negative sign in front of it, right? There you go. Boom, right? And we have all the crossings. Okay, so for this one, right, which is negative pi over 4, -1. So if you mark it, so this is a negative pi over 4. Oh, that's too thin. Okay, this is a negative pi over 4. And the purple, okay. So if we are to mark it, this is a -1, and the orange is negative pi over 4. If you recall the process with graphing these pictures for tangent, and they're just, you know, they're consistent, right? So then you plus pi minus pi. So in between each, that's difference is pi, right? So this is a pi. So that's plus k pi. So plus 1 pi minus pi, you know, plus 2 pi minus 2 pi, and so on and so forth, right? So the solution, so tangent angle equals to -1, the solution would be negative pi over 4 plus k pi, and k be any integer. Okay. So now let's look at the last question. I'll probably give you one more. Okay, so example number 4, not special, not special, right? It's a negative. So we're gonna do method 1 and 2 at the same time, right? Method 1 and 2 and at the same time. And make some modification. I'm making some modification. I'm making the modification right in front of you because I want you to see it. Okay, you see what has changed. Only the number has changed. Only the number has changed. And this number is to be replaced, right? And this is the and we need to make some adjustment to the picture. We need to make some adjustment to the picture because this time it's not going to be the unit circle, right? This one is more or less like a unit circle, right? But I'm going to draw one that's not a unit circle. So I'm going to draw a different picture, but a similar. Okay, so I want you to see the similarity by leaving them there. Okay, so now this triangle, we know you see here, hold on, let me write it down here. Okay, so basically you can write this as, you can write it in different ways, right? You can write this as -5/12 or 5/-12. 5/-12. All right, so for this question, we have, -5/12. So we can write it as -5/12. In this case, y is -5, x is 12, or 5/-12. They're all the same numerical value, but y equals to 5, x equals -12. So what I'm doing here is that I'm going to make a picture. I'm making a picture. So this picture is going to make that, there's some error in my plotting. Okay, so let me just redo it. Just redo the picture. Okay, excuse me. It's not going to take too long, so please do it along my side. Okay, so I'm making this, I'm making some adjustment to the picture, and this is not a special surface. This is not a special triangle. It's not a special, it's not unit circle, in other words. Okay, it's just an arbitrary points, right? As is given in the definition. Okay, so this is 1.125, right? X is 12, y is -5, and this is a -12.5. So we get those points, right? So the points are, one is 12, one is a -12.5, right? So that's a dot. And this is and there's another one. The other one is 12, -5. They all come up with the same ratio. They all come up with the same ratio, right? You see? And then the rest is just red, blue, okay? So we're gonna draw these. Okay, so draw the terminal. Draw the terminal. And draw the terminal. Draw the terminal. So we have the terminal. Oops, where's the other one? Where's my other terminal? Oh, there. Okay. And red and blue, you can draw the red blue, but really the red blue really is not necessary to draw. I'm going to draw it to you anyway because I want to enhance these figure, color, and whatever that help us understand. Okay, so let's see. Over here, so this should be the blue. Okay. This should be the blue. There. Okay. And Blue, 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 give me the blue. I want it to be thicker. And I'm gonna add another blue. Okay, so that's the other blue, you see? And the red. And the red. Okay, so I'm adding the red. Once again, it's not entirely necessary to draw these red and blue. Okay, but we draw this red and blue for better understanding. So anyway, so we got the red and blue, but what you really need to draw is the terminal. And these two terminals, and you mark the angles. I will mark this angle because this angle can be represented using arctangent. So this is my theta, right? Because for arctangent, quadrant 2 and quadrant 3 are crossed out. And these two angles, once you get theta, you plus pi and plus 2 pi and so on and so forth. It's a plus 2k pi, plus k pi situation, right? It's a plus 2k pi situation. And there we go. We got theta, and theta equals to tangent, arctan, negative 5/12. That's it, right? And our solution would be what? You got it. Will be theta plus k pi. Okay, k being any integer. See, we're done. We're done. So let's see how we're going to show our work nicely. Let's see how we're going to show our work nicely. So before I do that, I think I can do one more thing. Just make it nicer. Okay, I want to mark this angle. I can totally mark this angle, theta. Okay, it's not ideal, but so I cannot write the Greek letter in here. I just have to use the similar one by pronouncing. Okay, so it's a -1. Okay, so yeah, I think that should be fine. So theta. So this is just to mark this angle theta. Okay, it's not the best, right? It's actually my original picture is better. Okay, so when you write on paper, there's so much more flexibility. Of course, some of you also write on the handwritten on iPad and others, media. That's fine too. So let me show you how do you show work. Okay, how do we show work for this piece, right? So here's the question, right? So show work, and here's the question, and that's the answer you've given. So what do you need to attach? You just need to attach this picture. Okay, you can use a unit circle as well if you want, right? Actually, I don't like this data. Just mark it using the paper. Okay, handwriting it. Okay, I always find for handwriting is more convenient, but to make it clear for the recorded lecture, I commit to type it, right? But anyway, so that's how you answer this question. You're done. You're finished. Okay. Last but not least is the third method. Method 3. I want to emphasize the importance of understanding all of these methods because it's going to add so much ease to your future work. It's going to add so much ease to your future work, okay? So our question here is tangent equals to -5/12, right? So you just draw a horizontal line, and that horizontal line is y equals to -5/12. You see, -5/12. There you go, right? And the solution, we know the solution, don't we? We know the solution, but what are the solution, right? So what are the relevant markings that you should put on the solution, on the piece of graph you put in there, right? So here's what it is, right? Since this, of course, you need to specify theta, okay? Did we specify the theta in the previous story? No, we need to specify it. Okay, where theta, you always have to specify every symbol you have used. Okay, arctan of -5/12. Okay, so always specify every symbol you have used. Okay, so we didn't do that, we make it up. We make it up, okay? If you don't, you run the risk to lose points. Okay, you run the risk to lose points. All right, so the solution, of course, all of these points give us a solution, and all of these have the same ratio, tangent ratio, of course, right? The same output, -5/12, -5/12, -5/12, right? And what is the solution? The solution is the orange. It's the arc length or the angle input, and plus k pi, right? Plus k pi, this is 1 pi, and this is another pi, right? So you can see under the special case, special terminal case or non-special terminal case, no difference, okay? So solution is there, and this is the understanding. If you can mark all of these to your professors, and she or he will be really impressed. After all, when you show work, you show how well you understand the material. So you want to put your material in logical order so the reader could understand, okay? And sometimes you need to pretend that you know it and the reader doesn't. You need to, you're going to explain to the reader so that your reader understand what you understand, right? So that takes effort. You don't want to confuse your reader, and you want to be very clear, okay? That's how you get the points you deserve. Excuse me, okay? So now, without further ado, let's do, as always, we have another example, right? In the sine cosine case, in the sine cosine case, we have examples such as sine equals -3, cosine equals to 4, and so on and so forth. Let's have a tangent, right? If a tangent equals to 12. Yes. Okay. Can you say there's no solution? Can you say there's no solution? No, there's a solution. Why? Because the range of tangent is from -infinity to +infinity. As a matter of fact, okay, I'm going to straight to show you the method of the third method, right? I'm going to draw the horizontal line 12. I'm going to draw the horizontal line 12. Okay, I'm going to draw horizontal line 12. You're going to see the crossing. We actually see the crossing, don't we? Yes, we do. In fact, if you have a tangent, because the range of tangent, right? The range of tangent, so let me write it down. The range of tangent is all real numbers, i.e. it's from negative infinity to positive infinity. What does that mean? That means no matter what horizontal line you draw, you're gonna touch the curve. And no touch, no solution. If there are touches and there are solutions. Let me say it again. If there are no touch, no solution. But if there are touches, there are solutions. Okay, that's plain and simple. That's plain and simple. Now the question is, what is the solution? What is the solution? Right? What is the solution? Well, we have many, many solutions, right? And since this is a positive ratio for tangent, right? And we know that it's going to be, positive ratio, and we're going to introduce theta equals to arctangent 12, and this is going to be an angle, and this angle is going to be between negative pi over 2 to pi over 2. In particular, it's going to be from 0. Okay, in particular, okay, we have discussed similar things in other settings, right? In particular, that theta is also, in particular, it's between 0 to pi over 2. Okay, so it's even a better, assessment about theta. So theta is here. Theta is here. Okay, so this point. Okay, so let me show you what is theta. This is theta. This is theta. Okay, and what is the ratio? The ratio here, this is 12. Okay, so this is theta. Theta. Okay, and that's 12. Okay, and then what's the solution? What's the solution? The solution, of course, is theta plus k pi. Okay, and k being any integer. And once again, right, between these 2 points, the difference is what? Pi. The difference is pi. The difference is pi. Okay, so all of these differences are pi. That's what a k pi. That's what the k pi is. Okay, and there are many theta, of course. There's only one theta, exactly one theta, but many solutions. So the solutions are here, theta plus k pi. Okay, so now we basically talk about method 3 here. How about method 1 and 2? Okay, how about method 1 and 2? Okay, so I'm going to show you method 1 and 2. Okay, so method 3 is talk about first, and how about method 1 and 2? Method 1 and 2, right? So I want to give you that perspective as well. It's very similar to this situation. It's very similar to this situation. Okay, because tangent angle equals to 12, right? Of course, the picture has to be different. It's slightly different, but it's going to be in first quadrant and third quadrant. So how do you make out the X and Y? So the X is 12, Y is, I'm sorry, the Y is 12, X, Y is 12, X is 1. Okay, so Y is 12, X is 1. Okay. It could also be what? Negative 12, negative 1. So it could be X equals to negative 1 and Y equals negative 12. So that either in the first quadrant or the third quadrant, right? So in this quadrant, the point is 1, 12, and in the next quadrant, the point is -1, -12. We don't get to see these numbers, these examples very often, but we know there are solutions, right? So now I'm going to have to make adjustment to these pictures, right? But it's not too hard to make these adjustments because let's do it. Okay, let's do it. Okay, so for 1 and 12, right? X is 1, Y is 12. Okay, this is -1, -12. Right? And -1, 1. 1, 1, 12. -1, -12. Okay, let's see what do we get. Look at that. Look at that. All right, we had to make some adjustment to the picture, right? Because we don't have enough space. So let's make it -13, +13, -13, +13. Oh, that's pretty ugly, isn't it? But that's the situation. That's the situation. Okay. So let me see how I can make the picture nicer. Okay, so I'm gonna make it, this is -3, +3. Okay, so this is better, right? This is better. They're not proportional, right? This is a 1 and this is a 5. But it doesn't matter as long as the picture is marked properly. And as we know the solution, right? So we know the solution. So we just have theta equals to what? Arctan of 12. Arctan of 12, what angle would that be? It's this angle. That's a theta. That's a theta. And of course, and plus k pi, you know, that's it. That's it, right? So for tangent, any output, okay, for any output here, you have a solution, okay? There will never be a situation you don't have a solution, okay? There will never be a situation you don't have a solution. Okay, so the answer, of course, is going to be theta plus k pi. Okay, k be any integer. K be any integer. Okay, so how to show word? That's it. You show this piece and you show that picture, that will be sufficient. And of course, there's a place here. There's a place on the unit circle, okay? There's definitely a red and blue in that picture. But, you know, you don't have to draw 2 pictures. So that's it, right? So to summarize, unlike in the sine cosine situation, or sometime depending on the output, right? If the output is outside the range, you have no solution. Tangent equation, you always have solution. You always have solutions, okay? And you always have many, many solutions. I hope that helps, okay? Thank you for watching. Until next time.